Hello, this is Danu, and today I'm going to continue reviewing the paper on a new kind of rays written by Wilhelm Conrad Röntgen in 1896, published in Nature, number 1369 and volume 53. If you didn't watch the first part of this video, go watch that first because we are going to continue from where we left off from the first video. Then, let's get started. So, in the part 1 video, we left off from where the paper, where Wilhelm Röntgen was talking about the density of the material objects and the permeability of X-rays on those materials, and where Röntgen concluded that the density is not the only factor for permeability determination of each different materials, and that is because the material called Iceland spar showed itself much less transparent than the other bodies, although it had approximately the same density as highlighted here. So in this video, we are going to talk about the next part, which is Röntgen comparing the X-rays to cathode rays, which the cathode rays are simply a beam of energy or electrons emitted from the cathode, which is the negatively charged side, to anode, positively charged side of a vacuum tube when powered by an electric current. After he discusses the density and the permeability of the X-rays on several different materials, he talks about the potential refractions that different materials can cause the X-rays to perform. And the whole left side of this journal talks about the refraction of X-rays and of different materials. And he concluded that because he didn't obtain any evidence of refraction at the surface of different media, it seems probable that the X-rays move with the same velocity in all material bodies, and that the molecules obstruct the X-rays more effectively as the density of the body concerned is greater, which is also connected to the part 1 video. Then, this is the main part of this video, which is about the comparing X-rays to cathode rays, which are just simply a beam of energy or electrons emitted from the cathode, which is a positively charged side, and anode, cathode, the negatively charged side, to anode, which are the positively charged side of a vacuum tube when powered by an electric current. I'll show the model later so that you can understand it better. Okay, so Röntgen first briefly mentioned Leonard, who investigated about cathode rays, and Leonard's investigations on the absorption coefficients of various materials for cathode rays, as highlighted here, and explains his experiments with the absorption of various materials with X-rays and similar pressures. Later, he illustrates that air absorbs less X-rays than cathode rays, and then concludes that X-rays and cathode rays are different. Although he doesn't explicitly mentions this, he implies this in his first reasoning. And then Röntgen further emphasizes the difference of the two rays involved with magnets here. For the cathode rays, Röntgen mentions that magnets can be used to identify several kinds of cathode rays. However, he could not observe any deviation of the X-rays even in strong magnetic fields, as the 11th paragraph here says. These statements displays that cathode rays have different kinds, those that are classifiable using different strength of magnets, whereas X-rays cannot be classified with that method. In the next paragraph, Röntgen introduces a third reason why X-rays are different from the cathode rays. Here he notes that based on his many experiments, it appeared to him that X-rays proceed from the point where the cathode rays strike the glass, as this model shows here. So this is the cathode and this is the anode. Here the electron beam, cathode rays, shoot to the anode side, and when the cathode beam strikes at the end of the glass, the X-rays are emitted from where the cathode rays strikes from the glass. And that's what Röntgen means with his paragraph here, that X-rays are not identical with the cathode rays because cathode rays cannot penetrate through the glass, but X-rays can, based on his many experiments, and that the X-rays are produced from the cathode rays at the glass surface of the tube. So he means that X-rays emitting right at the place where the cathode rays hit the glass, like this. He means it that, by illustrating it in this way. So here, Röntgen concludes that his three distinct characteristics of cathode rays and X-rays. First one was the different absorption rate of different mediums of X-rays and cathode rays, and second one was the distinction of the kinds of rays with the magnets and magnetic fields, and the third one was how X-rays are actually beginning or spreading in all directions from the point where cathode rays are hitting the glass. So with these three distinct characteristics, he asserts that X-rays are actually produced from the cathode rays at the glass surface of the tube that he used, which I already showed you with the model. So this was the second part of Röntgen's On a New Kind of Rays journal published in Nature. There's one part left in his paper, the third one, and I'll discuss that next time. If you're interested, keep in tune with my videos and you'll see the third part later. See you later. Thank you for watching.